Once you've loaded StatTools, you can run linear regression, logistic regression by the following procedure. So we have our variables here, and this data set isn't finished. I've started to code some of these non-numerical values as binary. So for ever married, we made married binary, and then we said if yes, 1, otherwise 0, so that we could use it in our logistic regression. Same for the types of work. So there were 5. So 1, 2, I would have had to make 5 here, plus the residence type as well, and then the values for smoking. So if that were completed, I could then use StatTools, which is now loaded after downloading it from the Cengage website, which can be found, the link in the book. This is the student site, so you would go click Palisade Decision Tool Suite, and then you would click here, and then you would have to fill out a little bit of information to get the book. So we would choose our textbook here, and then fill out this information and download the trial version. Now I have it loaded in. If I go to StatTools, the first thing I have to do is add in my data set. So I'm going to add the entire table as my data set. It's smart enough to recognize that I have a table, that my names are in the first row, so this looks good, and I'm going to call this data set stroke data and save it. Now I can come up here to regression and classification and choose logistic regression. Since my stroke is the values for stroke are binary, either they have a stroke or they have not had a stroke, I'm doing logistic regression because I'm trying to predict whether or not they fall into that binary classification. So linear regression won't work in this case because I'm not trying to predict the value of the dependent variable where it might be some calculated number. It's either going to be that either has or has not had a stroke. So in this case, as we learned in chapter 17, logistic regression is the best choice. So from here, I would choose for my dependent, I need to find the field stroke. And then I'm going to include my glucose level, BMI, and all of my other variables. I just have to make sure I'm only selecting the binary. So obviously I don't have all of them in here, so I'm not going to select all of them. I'm only going to select the ones that I know are numerical, just for this example. Hypertension and age as well. For gender, I would need to convert that to binary before I could include it. Okay, so once I've selected all of them, all of my dummy variables and my stroke as my dependent, I can run this and then just click OK. And then it's going to, oh, it didn't like BMI for some reason. I've been playing with this data set, so. Anyway, so now it'll run. And then once I get my results, I will interpret them to determine which variables were significant and which were not. And then I will drop those out of my regression and run it again with only the significant variables. So after this runs, it will look a lot like an ANOVA regression, and we can check the p-values for all of the coefficients. Okay, here are my results. I'm going to look at my coefficients I ran for these fields here, check my p-values. So these three p-values are too high. So I'm going to rerun with just, well, in this case, because I don't have gender or my other variables in here, so I would have to check for all of them. But in this example, I can keep these three and rerun the regression with just the variables that had significant coefficients.